Test, 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 1, 1, 2, 1, 1, 2, 1, 1.
On the 6th of February 1990, ministers and high-ranking officials, as well as representatives of European industry and scientists from member states, gathered at the European Southern Observatory to attend the inauguration of ESO's revolutionary 3.5-meter new technology telescope. This celebration took place simultaneously at the headquarters in Garching near Munich in West Germany and at the La Silla Observatory in Chile. The two sites, 12,000 kilometers apart, were connected by a live TV link.
Welcome to this NTT inauguration press conference. I would like to say just a few things about the NTT, knowing that you have all received a press package, that you're already exceeding...
There were about 50 media representatives from all over Europe at the morning press conference.
And it will be very important scientifically for the next 20 years, at the same time as essential, as experience for our engineering for the VLT in the future. And so that's why today we celebrate the efforts made since 1982, but also, if you like, the ability now to use the experience of the NTT and put it into the VLT.
Dr. Dickman.
Well, I have a two-part question. The first is simply if one of you could outline some of the contributions to basic science that you expect the NTT to make.
The NTT will have a better, what we call point source sensitivity than any existing telescope. And therefore, it can either see fainter objects at a given distance, or it can see the same objects at a greater distance. Secondly.
Question? Yes, Herr Weiss.
I have the impression it's interesting to get some ideas and comparisons on the budget, the money which was involved to build such a new instrument. Usually, developing a new instrument means developing a new budget.
And we have completed this project on time and also well on budget. Out of these 24 billion, we have spent roughly, this to give you an order of magnitude, a third for the optics, including optomechanical component, a third for mechanics, and a third for building and infrastructure.
And if you compare the cost of the NTT to the cost of its of the 3.6 meter, which was built, roughly speaking, 10 years before or 15 years before, there is about a factor of 2, roughly speaking, a factor of 2 per square meter of collecting area.
Many questions focused on the NTT's performance.
This figure you quote, 80% of the geometrical energy in 0.135, is in fact the figure for the manufactured optics. In other words, the chain of the 3 mirrors on their own when the thing is fully optimized. Now, when you set that we can get 80% of the energy reliably within 0.2 arc seconds for all the effects in the telescope and all the effects in the local air.
In 5 minutes exposure in the visual region, for those who know it, in the Johnson D filter, the NTT shows stars under good seeing conditions which are fainter than 24th magnitude. If you are familiar with the performance of, say, old telescopes which were built for 10, 20, 30 years ago, this is a very impressive performance. The remote control is an important feature, but it is a technically very complicated feature, and perhaps it would be useful if Manfred Ziebel would just say a few words about how it really functions.
We have connected on both sides a computer. The computer at La Silla is already the telescope control computer. Here we installed another one to make best use out of the bandwidth of such a telephone line.
And this image is point 6.
The manager of the NTT project was enthusiastic about the new telescope.
When the telescope is almost horizontal, the active optic correction, the building, the mechanics work so well that we really use the unique possibility of La Silla to the best.
Bavarian Television was on the spot to transmit the transcontinental events in an extended evening program. Meanwhile, as the last preparations for the formal inaugural ceremony were carried out, reporters from radio and TV used the opportunity for obtaining individual interviews with prominent visitors and high-ranking ESO staff.
ESO ist eine internationale Organisation mit 8 Mitgliedstaaten. Sie ist auch eine astronomische Organisation. Und die Astronomie verbindet uns.
Crews from 5 TV stations followed the inauguration ceremony in Garching. The events at La Silla were covered by Chilean TV, which also provided the headquarters with live images transmitted via satellite. In the auditorium, the guests took their seats, and the inaugural session was then opened by ESO's Director General, Professor Harry van der Laan.
Your Excellencies, honored guests, ladies and gentlemen. It's a pleasure and a privilege to welcome all of you in ESO headquarters and on our La Silla Observatory in Chile to this festive dedication of our new technology telescope. This is one event on 2 continents. ESO's 2 major sites connected by several electronic communication links. ESO's guests and ESO staff present and participating on a sunny afternoon in Bavaria and on a summer morning at 2,400 meters high in the beauty of the Atacama Desert. Note that this imaginative project could only be realized because all member states agreed not to profit from this entrance fee to reduce their own contributions. And thus it became possible to enhance ESO's capacity in the form of total telescope time offered through an addition to its suite of telescopes, an enhancement required by the enlargement by the Italian and Swiss astronomers of the user community by about 25%. From that set of decisions to this day, a lengthy path has been traveled.
However, the image quality aspect is that feature which is unique in the NTT and we believe a milestone in telescope development.
ESO's senior optical scientist, Dr. Ray Wilson.
Image quality in the NTT. First, the concept of active optics. Second, the figuring quality for the 3 mirrors as achieved by the firm of Carl Zeiss based on this concept. And thirdly, the building concept around the alt-airs mounting which maintains optimum conditions of the local air. Now coming to the active optics concept, the first point, this is a perfectly classical feedback control system which looks like this. A star image in the field of the telescope is fed into the image analyzer, that's the upper box on the left. Its results then processed in the microcomputer, the lower box, which sends signals to control the position of the secondary mirror and also the supports of the primary mirror.
The NTT project manager, Professor Massimo Tarenghi.
23rd of March, 1989, remote control was used to receive images in Garching via satellite. Remote control from Europe will become a routine procedure with the NTT telescope. The first results have surpassed even the great expectation we had at the beginning of the project. What counts is not only the perfection of the optics and the mechanics, but the unique design of the whole system, the combination of a rotating building and telescope in one machine, able to produce the best possible picture of the sky. The NTT has opened up new observation frontier for astronomers, and it has significantly narrowed the gap between the potential of ground-based telescope and the space telescope.
Professor Tarenghi's speech was followed by the first presentation of the new ESO film, Window on the Universe.
few sights are as beautiful as the millions of stars stretching across the southern sky.
Your Excellencies,
Professor Per-Olof Lindblad, president of the ESO Council, began his remarks with a quote.
Astronomy is, as the Finnish philosopher Georg Henrik von Wright would classify it, an epistemic science. The motive force of its scientific enterprise is the strive for knowledge, the urge of man to find out for himself and independently of being told how things are, to find out about the universe in which he lives. The aim of astronomy is not to advance technology. However, to provide the very best, astronomers need the most advanced technology available. Because of the unique and often very extreme requirements put by astronomy, astronomy has often been the driving force and inspiration to push technology to its very limits. This is why this new technology telescope is such an important tool, not only to pursue the final aim of astronomy, but also to be a test bed for development of technology for our next big project, the Very Large Telescope. Without European collaboration and generous support by our governments, the very impressive constructions in the remote mountain desert of Chile could not have been achieved. This collaboration has been of fundamental importance for the advanced position of European astronomy today.
Thank you, Professor Lindblad, for this contribution and for your leadership in Council. We see now on our screens the live images of our other site on La Silla. So that is not a film, that is what is happening right at this very moment.
Our Italian and Swiss colleagues had maintained a keen interest in our evolution and realized that La Silla had still some space for yet another telescope.
In Chile, Daniel Hofstadt, head of the La Silla management team, spoke to the guests, which included most ambassadors from ESO member countries, as well as Chilean officials. The guests were seated at the platform on top of the NTT service building.
In front of us. New technology in the domains of optics, mechanics, and communications had been tested and were not unfamiliar to our staff. Clearly, the time had come to crystallize our ideas and courage into a different challenge. And today, we're turning over to the scientific community a truly exceptional tool to reach a deeper grasp into the universe.
We now continue our activities here at headquarters.
Per l'Italia l'occasione odierna assume un significato particolare. L'approvazione di questo progetto è stato voluto con grande determinazione dal mio governo. Con l'ingresso nell'ESO l'Italia ha inteso anche dare un contributo alla realizzazione dell'NTT.
Professor Ruberti, the Italian Minister of Universities and Technological Research, noted the important contribution made by his country to the NTT.
Questo sostegno manifestato senza riserve in passato è confermato dal mio governo ancora per il futuro. Sulla linea di sviluppo dell'NTT si è inserita la recente decisione di avviare un progetto ancora più ambizioso, mirando a dotare gli astronomi europei di uno strumento di osservazione ottica che sarà il più potente del mondo, il VLT, per la cui realizzazione ci si può avvalere dell'esperienza dell'NTT. Ricordo che il mio predecessore è stato il primo fra i ministri della ricerca degli Stati membri ad esprimere pubblicamente parere favorevole a questo progetto, nel convegno tenutosi a Venezia. Abbiamo sostenuto allora il VLT e lo sosteniamo ancora oggi perché l'Italia crede molto nel valore della collaborazione scientifica internazionale, in particolare perché desideriamo contribuire a mantenere all'ESO quel ruolo di preeminenza mondiale al quale oggi è giunto. Lo sviluppo di una sempre più ampia collaborazione internazionale è una delle nostre priorità e ad essa intendiamo dare un contributo significativo rafforzando parallelamente i programmi nazionali.
Your Excellencies, Director General, ladies and gentlemen, the inauguration of
Ambassador Keusch from Bern represented the Swiss government.
is a very special event in the history of European scientific and technological cooperation. Compared to ESA, the European Southern Observatory is small in terms of its budget and number of personnel. But the events we are watching and indeed participating in are proof that a successful scientific endeavor, even in our times, must not necessarily cost billions. Not only are we inaugurating today the world's most modern and most performing optical telescope, we are also writing technological history by cooperating this glittering jewel, sitting high on a mountain, top on the other side of the world, by remote control via satellite from here at Garching. The Italian and Swiss entry fees have been transformed into this splendid example of scientific ingenuity and technological innovation. The other key role of our new telescope is, of course, that of a technological predecessor to the Very Large Telescope, VLT, decided by the member states in December '88. This time, there is not such a special contribution. ESO's budget will have to be increased considerably, but I am confident that member states will honor their commitment and that the executive, building on its experience with the NTT, will cope with this new challenge successfully. Thank you.
Meine sehr geehrten Damen und Herren, als deutscher Minister begrüße ich Sie besonders gern in Deutsch. Pero al mismo tiempo quiero que saludar a las excelencias y nuestros amigos en las islas que han contribuido durante los últimos años tanto para el éxito de nuestro trabajo aquí. Knowing that, I have to submit
Professor Riesenhuber, the German Federal Minister of Research and Technology.
To the English. Ladies and gentlemen, what we are presenting now is a new instrument for the science. That it has been accepted in the past years by the young scientists, that they are cooperating in the best possible instruments with the best possible spirit. This is the task of the future. I think what we have to achieve is that we are going increasingly to understand that jointly we can achieve goals which are beyond the reach for any single nation, in basic research, in coping with the problems of the environment, in new and very large technologies. I think what we have erected here as a piece of equipment is the possibilities of applying excellent instruments to pure science. This is a challenge for the young generation, which finds together in joint efforts over the borderlines of the countries. In this spirit, I wish a good success to NTT, to the coming VLT, to the spirit of our scientific community, and to integration of all our scientific nations in one worldwide community which will coin its path for the future.
The next action is that Monsignor Cox, the Bishop of La Serena, will bless the telescope.
Following this, the French Minister of Science and Technology, Monsieur Curien, addressed the guests.
Mes chers collègues, après le geste symbolique et très émouvant de Monseigneur l'archevêque de La Serena, j'ai le devoir un peu ingrat de vous ramener du ciel vers la terre. I would first underline the major interest of European association, European organization like ESO. ESO is not the first one. It's not the biggest one, but it is one of the most interesting one, of the most fruitful one. Now, being an astronomer in Europe, it's a must to cooperate with ESO. A second point concerning ESO is that it's a very big center for studying instrumentations. And not only instrumentation for telescopes. All what you have done here in the frame of ESO is, of course, very fruitful, very useful for astronomers. But there are many spin-offs of the technology you studied here on many fields of physics and on mechanics. And I think that also for Europe it's really of a great value. Another point I wanted to say is that here in ESO there is a place where people are meeting to discuss their planification, their hopes and their needs for the coming years. And just to conclude, je voudrais vous souhaiter à tous, à l'ESO, à tous les collaborateurs de l'ESO, le meilleur succès, un superbe résultat pour ce télescope qui vient d'être béni et inauguré, et aussi une très belle réussite pour la prochaine étape, le très grand télescope.
Now, ladies and gentlemen, there is one item on the program so secret that I did not want it printed on the program, and that is coming now.
Professor Terenghi was elevated to the rank of Commendatore dell'Ordine al Merito della Repubblica Italiana by Minister Ruberti. And Dr. Ray Wilson received the Medal of the University of Geneva for his pioneering work in the field of telescope optics.
Ladies and gentlemen, this formally ends this inaugural ceremony. The scientific session will start with 3 speakers in 1 hour in this auditorium at 16:40.
On these faint objects which are associated with
George Miley from Leiden in the Netherlands was the first of 3 distinguished European astrophysicists to lecture at the scientific session.
About 10 galaxies
so many astronomers, some of which having even fundamental contributions to some of. Well, I will talk about.
He was followed by Franco Pacini of Florence, Italy, and finally by Gustav Tammann from Basel, Switzerland. All the speakers stressed the great possibilities for observation opened up for a number of different important astronomical fields by the NTT. Old star maps may be quite beautiful, but they do not represent the real sky very accurately. They show only the brightest stars. Star maps from the last century show fainter stars thanks to better instruments. This is a sky field in the southern constellation of Centaurus. The same field was photographed with the ESO Schmidt telescope. This globular star cluster is called Omega Centauri. It contains many millions of stars very close together. Look at the small area at the very center of Omega Centauri. On the Schmidt photograph, we see only a few fuzzy stellar images in this area. This photo is one of the best ones obtained with the ESO 3.6-meter telescope. It has sharper images and higher resolution, and we see more details. But ESO's new technology telescope is even better. Its images are almost 3 times sharper. We see many more details. We can sharpen the NTT images further by image processing. Now they are almost as sharp as if the NTT were in space. Sharper images mean that we can see fainter images. It's just like focusing the telescope. The fainter the objects a telescope can observe, the further we can look out into the universe. This is a 2-hour exposure from the ESO Schmidt telescope. A very faint and distant globular cluster was discovered on it. The NTT photo shows much more detail and also fainter stars. The exposure time was only 10 minutes. This rather bright star has magnitude 18, and this faint one has magnitude 25. It is 40 million times fainter than what can be seen with the unaided eye. The NTT can observe fainter objects than any other ground-based telescope. There are many beautiful nebulae in the Milky Way. They shine in many colors. This is the Rim Nebula. And this is the bright Omega Nebula. Stars are born in nebulae like these, as well as in the large Orion Nebula, which has a very complex structure. There are strangely formed small nebulae near some stellar birthplaces. From some of the infant stars, jets of fast-moving material stream outwards. The nebulae are found where these jets ram into the surrounding interstellar material. Now, some high-resolution NTT photos of these nebulae. They are called Herbig-Haro objects, and they shine in the light of highly excited atoms. Other nebulae in the Milky Way have more regular forms. These are the so-called planetary nebulae. They come from dying stars that throw off their outer layers, which then form nebulae around them. Some of these nebulae are very beautiful, and some have rather peculiar shapes. This is the famous Crab Nebula, photographed by the NTT in different colors. It is the remains of a star that exploded as a supernova in the year 1054. In this infrared image, we can easily see the famous pulsar at the center. The Large Magellanic Cloud is a satellite galaxy to our Milky Way galaxy. It contains a number of nebulae that shine in ultraviolet light. They are remnants of supernova explosions long ago. The NTT image shows the beautiful filamentary structure of this one. Another one looks like a swan, and this one has 2 narrow loops. This is an NTT photo of the light echo around supernova 1987A. The supernova appears to have blazed a trail through the interstellar matter, and the nebula around it now looks like Napoleon's hat. At the very center, there is an oval nebula, only 2.5 arcseconds across. It consists of matter lost by the star before the supernova explosion. The good resolution of the NTT now makes it possible for us to see it. Not very far away from the supernova is the large Tarantula Nebula. This is an NTT photo showing the very complex structure near its center. And this is the central stellar cluster. The Fornax dwarf galaxy is almost 700,000 light-years away. It is the only known dwarf galaxy with globular clusters. The NTT picture of this cluster clearly shows the individual stars for the first time. Now we can begin a detailed study of them. Other dwarf galaxies are more irregular. The NTT also shows individual stars and nebulae within them. NGC 300 is a large spiral galaxy about 10 million light-years away. It looks like the Milky Way, the galaxy we live in. With the NTT, we can observe the stars in this galaxy and also the detailed structure of its many nebulae. This is the center of another galaxy, NGC 1365, about 65 million light-years away. This NTT view of the inner regions of NGC 1808 gives us an impression of the violent motion in this very active galaxy. There are many luminous knots at the center. Some galaxies have wide dust lanes. This is not the famous Sombrero galaxy, but NGC 681, which is much smaller and fainter. NGC 2992 is also quite dusty, and so is the beautiful spiral NGC 613 and the barred galaxy NGC 6300. This huge pinwheel is the famous NGC 1068 of the active Seyfert type. And this small group of strange-looking galaxies was first found at ESO some years ago. The NTT enables us to see in great detail how gravitational interaction has distorted them. Distant clusters of galaxies will be one of the NTT's main observing fields in the future. The first test observations have fully confirmed its ability to provide sharp images of faint galaxies in even very distant clusters many thousands of millions of light-years away. The quasars are even further out in space. Some of them, like this one called the Einstein cross, have multiple images very close to each other. Here you can see 4 images of the same quasar. This is what's known as gravitational lensing. On this short exposure NTT image, we can see the lensing galaxy that split the quasar light and also the 4 quasar images in the middle. From technically simple, easy-to-use instruments, we have advanced to extremely complex computer-controlled telescopes like the NTT. Observations from the control room have already begun with this new telescope. The NTT opens new horizons for Europe's astronomers, and during the coming years, the NTT will provide them with new, exciting discoveries. With the NTT, they will be ready to make the best possible use of ESO's next super telescope, the 16-meter Very Large Telescope.